Hey everyone, welcome back to my channel EduVibe. Today we will start with the third unit of grade 12 physics, which is the unit C, electromagnetic radiation. So far we complete with the two units, momentum and impulse and forces and fields. Now we start with third unit, and after it we start with fourth and last unit. So in this unit we'll learn about electro and the magnetic radiations, and we learn more about the radiations, that what are radiations and how the speed, which is the speed of this, and these all topics we cover in this. We cover the mirrors and lenses too, reflection and refraction too. So our today's topic is electromagnetic radiation. We do the introductory part today, and later on we move on to the next parts of this unit. So let's start with this and say that what is electromagnetic radiation, and the short form is this EMR. So EMR is the radiant energy which travel outwards, that is radiates in all direction from its source. So we have some one main source, and the radiations go outwards means they travel outwards like this, travel outwards, and which they radiate in the direction from the source, in all directions from the source. After that, for a particle to produce EMR, so for any particle, if they want to produce any electromagnetic radiation, both the following conditions must be satisfied. First one is they must be charged. So anything must be charged in that case, and they undergo acceleration. So they involve the acceleration, they must be undergo acceleration, and the particle should be the charged particle. Electromagnetic radiation is produced through the acceleration of the charged particles. When the charged particle do accelerate, then the electromagnetic radiation is produced. So that's the main point in this, that when it produces, when they start radiating things. So that's you all have to know in this. Next thing, that how we distinguish between the different types of electromagnetic radiations. So they depends on the different properties they have. So the different properties they have, such as the source. So firstly, their source where the radiations originate. That is the sun, high energy electron, and nuclear decay. That high energy electron and nuclear decay, we learn more about these things in the next or the last unit, atomic physics. So for now, we'll just focus on the sun energy. When the sun has the source source of electromagnetic radiation, we just focus on the sun mainly, not with the high energy electron or nuclear decay, but they are the other source of this electromagnetic radiations. And second thing is the frequency. We learn about the frequency more in this unit now, and which is the number of cycles per unit time. So in particular amount of time, in per unit time, at how number of cycles they do, how many times they go the cycles of electromagnetic radiation is called the frequency. So it also depends on the frequency. Last thing, the wavelength. We learn more about the wavelength in this unit too. So which is a distance between the adjacent points that vibrated in phase with one another. When things then vibrated, so the wavelength can be generated. So this is the wavelength. So these are the wavelengths, and their propagation of the any type of wave you can see. So this wavelength is this also shows the frequency, that how many frequencies they go, and this also shows the wavelength of the any particular particle, any particular cycle of this. So that's all you have to learn in this, that how the properties of the radiations distinguish between different types of electromagnetic radiations. Next thing, we have the universal wave equation. So for this, to calculate the any kind of thing, you learned this formula already in the grade 11th physics, which is that V is equal to the frequency times wavelength. V is the speed of the wave, F is the frequency, and wavelength is the wave. So that already you done in the grade 11 physics, that the frequency of the wave is constant as is directed by the source. When directed by the source, any frequency of the wave should be constant in that case. And this is still true for the electromagnetic waves too. The frequency remains constant. Once the wave leaves the source producing the vibrations, the frequency remains the constant in that case too. But we don't use this formula anymore, that V we don't use. Instead of V, we use the C letter. The C, which is C. So I will do this over there. So firstly, I have to know about what is frequency and period. So frequency versus period has the relationship. They have an inversely proportional. So which means that frequency is equal to 1 times t. That t is not the time. This is the time it takes for the wave to complete one full cycle. This is also known as the period. This is also known as the period. We take it as a time because it has as a unit of seconds. So that's why we take it as a time. But this is the period. This formula is given in your data sheet too. This one too, or this one. Units of wave with electromagnetic radiation. And this F is the frequency, the hertz. Also, all the electromagnetic waves in a vacuum travel at the speed of light, which is c. Now, from here you get the c. The speed every electromagnetic radiation has travel in the vacuum where there's no air. At that vacuum area, the speed of the light, which is v, which is also called now c, is the 3.0 into 10 raised to power 8 meter per second in the vacuum. So that c you have to use instead of now v. So from here you will get the formula that universal wave equation for the electromagnetic radiation is c is equal to frequency times wavelength. So that c is the speed of light, which is 3.00 into 10 raised to power 8 meter per second. This formula we use number of time in this unit, in the next unit too. So that thing all connected to the whole unit. And this formula we use a number of times in upcoming lessons. So you have to know this formula. This formula is on a formula sheet. So yeah. Next thing, as our waves will be traveling in the uniform medium. So always the waves are traveling in the uniform medium, which is the state medium. They do not undergo any acceleration. Thus, we use only v is equal to d upon d for any kinematic analysis. We can't use that complex kinematic analysis equations. We just use this if we want for the kinematic, for any kinematic calculations. Or we use the equations we do in the electron lessons because we do number of formulas in this. So last thing we have to discuss before the example is that frequency and the wavelength has the again very important relationship for both. So from the universal wave equation, we know that the frequency and the wavelength have an inverse relationship. So they have an inverse relationship. So that's why if the source frequency is high, so the wavelength is short. Wavelength is short or long, and frequency is high or low. So the source, if it's high, the frequency is high, wavelength is short. If its frequency is low, the wavelength is long. So as you can see over there. So this is the frequency or the wavelength of your any source you have to calculate. You guys just know about these things. Not you have to like know this diagram. You have to know this. So I have an example for this. So we have to determine the frequency of the ultraviolet radiation with a wavelength of 200 nanometers. So what you have to find? We have to find the frequency. So they given to us the wavelength, which is this. So you already did the formula, which is c is equal to frequency times wavelength. You have to find the wavelength. So wavelength is equal to frequency is equal to c upon wavelength. So which is c. C is always 3.00 into 10 raised to power 8 meter per second. And wavelength is 200. And this nano has the value of 10 raised to power minus 9 meters. So from here you get the frequency. When you divide this, you get 1.50 into 10 raised to power 15 hertz. So this is your frequency in hertz. So that's unit is hertz always. So that's how you can solve the simple equations. But some you don't get like this type of thing. You get the more complex thing like this one sometimes. So what the question says is that the source vibration conveys 2.5 into 10 raised to power 10 cycles in 3.00 minutes. Determine the wavelength of the electromagnetic radiation in vacuum that it produces. So what you have to find? You have to find the now wavelength. So wavelength has to be found, but they given us the not anything directly they gave us, but they gave us that the source term is this type of thing. So cycles word is our key word in this. So because of the cycles is there, and we know that the frequency is the number of cycles per unit time. So this means that this whole thing goes to the frequency. This is the frequency. So the frequency is also the cycles per unit time. So this means our cycles is like 2.53 into 10 raised to power 10 at the time. Time should be in seconds. So 3.00 into 60. So you get 180 seconds. So 180 seconds, and this is this thing. So what do you get? You get about 1.405 sets repeating into 10 raised to power 8 hertz. So you get this frequency. Now you know the formula. Formula is this. To find the wavelength, C upon F. So C is again 3.00 into 10 raised to power 8 meter per second divided by 1.4056 into 10 raised to power 8 hertz. So what you get as a wavelength? You get 2.13 meters. You get 1.3 seconds. So this is your wavelength of electromagnetic radiation the vacuum that is produced. So you get this type of questions that this thing you have to know. So that's all we have to do in the next part now. So this is the introductory part. Now we're doing the more things in this unit. Like we start with the how that speed of that, like the speed of the vacuum, speed of light in the vacuum is how it can be get, not the any other value. So how this the value discovery, we'll learn about this. We learn about the spectrum in next lesson. So yeah, we have to learn this now. So like myself with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.